Welcome back, everybody, to lesson 4.7 about LHopitals Rule. So LHopitals Rule is going to be a method that we have for finding limits of indeterminate forms. So there are going to be four major indeterminate forms that we're going to look at. So let's get cooking talking about LHopitals Rule. So sometimes we took limits, we couldn't do it. We ended up with what's called an indeterminate form. So in this case, when I tried to substitute in 0 right here, if I tried direct substitution, I get 0 over 0. So this was the indeterminate form that we dealt with the most. So this is our first type of indeterminate form, and LHopitals Rule only applies when I get an indeterminate form when I try direct substitution. So let's look at what LHopitals Rule is. What it says is that if I'm looking for the limit as x approaches a of some kind of quotient, f of x over g of x, then what I can do to find that limit as I approach a is take the derivative of the numerator and the derivative of the denominator separately, and then take the limit of this quantity. So note, here, this is not the quotient rule. I'm not taking the derivative of the entire function. I'm taking the derivative of the numerator and the derivative of the denominator separately. So let's take a look at this example down here. So again, when I try to substitute in 0 initially, I get e to the x is 1, minus 1 is 0, over 1 minus 1 is 0. So I get an indeterminate form, which means I can apply LHopitals Rule. Again, check to see if your form is indeterminate before you just start doing LHopitals Rule, because it might not apply if it is not indeterminate. So this is the limit as x approaches 0 of e to the x minus 1 over negative sine of x. This is the derivative of the numerator. This is the derivative of the denominator. So now I'm going to try direct substitution again. When I try direct substitution again, e to the 0 is 1 minus 1 is 0 over negative sine of 0 is 0. So I still get an indeterminate form. So what could happen with LHopitals Rule is you may have to apply it more than once. But as long as you continue to get indeterminate forms, you can continue to apply LHopitals Rule. So then I'm going to do it again. So this is now going to be the limit as x approaches 0. The derivative of the numerator here would just be e to the x. The derivative of the denominator would be negative cosine of x. And now I can actually do direct substitution. E to the 0 is 1. Negative cosine of 0 is negative 1. So this would be 1 over negative 1. So this limit would be equal to negative 1. All right, so that is our first type of indeterminate form, and that was 0 over 0. Again, that's the one that we've dealt with before. So there are two types of indeterminate quotients. So this is the first case of indeterminate form. It's indeterminate quotients. And that's when I get either 0 over 0 or positive or negative infinity over positive or negative infinity. So in either of these cases, we have an indeterminate quotient, and we can apply LHopitals Rule. So that was, we did the previous example for this case of indeterminate quotients. So the second case that we have is indeterminate products. So if we get a result that looks like either 0 times infinity or 0 times negative infinity, this is an indeterminate product. So we're going to want to make our function appear as a fraction before we apply LHopitals Rule. So what we can do is if I have 0 times negative infinity, I could rewrite this as negative infinity over 0 to the negative first, or as 0 over negative infinity to the negative first. Either way, my function now appears as a fraction, and I can start applying LHopitals Rule. So let's take a look at an example of indeterminate products. Also, I know that I'm going quick, but I want to get this video in a short time frame. So if you need to pause and go back and look at something, you can do that as often as you want to. So here's our example of indeterminate products. What I'm going to do is I'm just going to show us how we can rewrite it, and then we're going to do the example in class. So in this case, if we have the limit as x approaches 0 of x times ln of x, I can rewrite this as, well, first substitute in 0. The limit as x approaches 0 of x is 0, of ln of x is negative infinity. So I end up with the limit as x approaches 0 of 0 times negative infinity. So what I'm going to do is I'm going to rewrite this as a fraction, which I can now take this and I can apply LHopitals Rule. So we'll do the first step together. So this would now be the limit as x approaches 0 of 1 over x over negative x to the negative second. Some of you might be looking at this right now and say, oh, this is just going to be negative x. In class, we're going to finish this. So if you want to, try to finish this on your own and then bring it to class and we'll talk about it together. So those are our first two cases of indeterminate forms. So now we're going to look at our third case, which is indeterminate differences. So for indeterminate differences, after direct substitution, we're going to have infinity minus infinity. Basically, we're going to have two infinities whose difference should be 0 based on what we know about regular mathematical operations. But because it's infinity is kind of a concept instead of a number, we are not positive what it's actually going to be equal to. So in this case, again, we're going to want to write it as a fraction. And in order to do that, we're going to need to find a common denominator and write a difference that'll result in indeterminate form like one of the first two. So what we're going to do with this, again, is we're just going to rewrite it first. So a little bit of review on subtracting fractions. So this is 1 over sine of x minus 1 over x. So when I get a common denominator, this would be x minus sine of x over x sine of x. And again, for this one, double check. So right here it says we need to rewrite it so that it will result in an indeterminate form like one of the first two. So just check and make sure. If I substitute in 0, this is 0 minus 0 over 0. This results in an indeterminate form. And now I can start applying LHopitals Rule. So from here, we're going to finish this in class where we take the derivative of the numerator, the derivative of the denominator separately, and then try direct substitution. So let's look at the fourth case, indeterminate powers. So indeterminate powers, what happens here is after direct substitution, I end up with one of these three cases, either 0 to the 0, 1 to the 0, or infinity to the 0. So in any of these cases, we're going to need to create a fraction. And for this case, typically what we can do is we can take ln of the entire function, and then we're going to find the limit of ln of f of x and do that and find some value L. So because we took ln of the function back at the beginning of the problem to undo that, so to mathematically undo that, our answer will be e to the L instead of just whatever we get for this number L. So this one says in class, but I want to do this one so that you can see an example of this before we get to class. So in this case, when I tried direct substitution, right? So I tried direct substitution, I plug in 0, this is 0, 1 over 0, that approaches infinity. So this looks like 0 to the infinity power. So I'm going to go back and look at my, the 0 to the infinity should also be included here. So 0 to the infinity is an indeterminate form because I don't necessarily know what it's approaching. So 0 to the infinity is another indeterminate power. Oh no, sorry, I'm 0 to the infinity is not included. I'm having a day right here, guys. I'm dumb. And this is 0, so this is 1 to the infinity. I'm sorry about that, guys. So this is 1 to the infinity, which is an indeterminate form. So now I'm going to take ln of the entire function. So when I take ln of 1 minus 2x to the 1 over x, I can now apply my logarithm rules. And this is going to be ln of 1 minus 2x over x. And now I can apply LHopitals Rule because I've got a fraction. So I've got limit as x approaches 0 of ln of 1 minus 2x over 0. So I can take the derivative of this. So this would be 1 over 1 minus 2x times 2 over, oh my gosh, guys, this is not 0 right here. This is x. I'm having a day right now. But all right, and then this is all over 1. So really this is just 2 over 1 minus 2x. And now when I tried direct substitution right here, this whole thing is the limit as x approaches 0. I'm falling apart right here at the end, guys. Please bear with me. I will remake this video at some point, but I do not have time this morning. So this is the limit as x approaches 0. So if I notice right here, if I try to substitute in 0 here, I get 2 over 1. So this is equal to 2. So I need to remember that back at the beginning of this problem, this is times -2. This is -2. This is -2. Oh my gosh, guys. But I'm going to remember back at the beginning of this problem that I took ln of this whole thing. So my answer would actually be e to this power. So e to the -2nd. So that is it for today. Today's topics were LHopitals Rule, when to use LHopitals Rule, specifically with indeterminate forms, and we looked at a few examples. So if you have any questions, bring them to class. I will do better. I am about to fall asleep right now, but we will do this in class. I hope you took some good notes. I hope that you come to class with some questions ready to work, and I hope you have a fantastic day. I'll see you in the next video.